Hey guys, welcome back to another video. In this one, we're going to talk about inequalities and interval notation. Now, seeing as how this is an Algebra 2 video, we're not really going to be starting at the very beginning of inequalities. I'm going to assume that you've seen them before, but we are going to review what an inequality is and review how they're graphed. And we're going to focus really on how inequalities lead to this idea of an interval and this new notation we're going to introduce to make our lives easier. Okay? So let's start by reviewing what an inequality is. Well, a lot of times, or most of the time in algebra, we talk about a variable being a number. So x could be 2, or x could be 4. Or in the case of, say, if I'm trying to solve an equation, x squared equals 9. X could be both 3 and -3. But in all these cases, the variable is either one number, two numbers, maybe 3 or 4 numbers. But what if I wanted to talk about a whole big group of numbers, maybe an infinite number of numbers, something with a condition? Well, that's where inequalities come in. So with an inequality, I can talk about things like all the numbers greater than 2. And that's not just 2, 3, and 4, and 5, and 6. Well, actually, this one doesn't include 2. But it's not just 3, 4, 5, 6, 7, the whole numbers. This is also 2.75 and pi, 10 billion. It's anything bigger than 2. And this notation allows me to talk about all those things without having to list them all, which in fact you couldn't list them because there's an infinite number of them. So if you remember, there's a very simple way to graph this and to visualize it. If you put 2 on a number line, let's say here, and I'm not going to put all the other numbers on here. I believe in efficiency, so I'm just going to put as little information as possible on this line, and you can imagine, I'll do it this time, there's a 0 here and maybe a 1 here. But in this case, to draw what I'm talking about here, I want to consider all the numbers larger than 2. Well, on this number line, what numbers are larger than 2? Well, there's 3 and 4 and so forth. Those numbers are to the right of 2. So what we do, if you remember, we're going to put a little dot over 2. We're not going to fill it in because we're not including 2 right now. And we're going to draw this arrow this way to denote that all of these numbers, 3, 4, 3.5, all these numbers that make up this line, there's an infinite number of numbers on them actually, all the way out to forever, to infinity. All those numbers are the ones that we're talking about. Okay? Now, some people may have learned that if you look at this symbol and it looks like it's an arrow pointing to the right, you know that this arrow is going to point to the right. And that indeed is true, especially, well, if the x is on the left, that'll work that way. If that helps you remember this, then that's great. But I would encourage you to think about this in the way it's actually, what it means. So I want you to understand that this doesn't go to the right because this is an arrow pointing to the right. That's not why. It's just a convenient, thing that you can remember to help you. What's really happening is it's saying x is larger than 2, and where are those things? On the right side. That's really what's happening. All right, what about, just to be complete here, what about x is less than 2? Well, we draw our line. Here's 2. We've got I'm going to keep consistent with my red. Put the dot above 2, and it goes to the left. Again, not because the arrow points to the left, but because we're talking about numbers less than 2. And where are those numbers? On the left side of 2. But again, if you want to remember that that's just an arrow that points that way, you can do that. There's no problem with that. Well, what if we wanted to include the number? Let's try something else. Let's pick another number so we're not just always using 2. X is greater than or equal to 3. Now we want to talk about not just numbers bigger than 3, but we also want to talk about 3 also. So that's 3, 3.1, 3.25, 4, 67, all kinds of numbers. Everything bigger than 3, including 3. Well, we do the same thing, but this time we're going to close the dot in, right? And then we're going to put our arrow going that direction. And you could do the same thing, just for completeness sake. I'll do it the other way too. Less than or equal to 3, and here's my line. Here's 3. And I fill in the dot and go that way. All right, hopefully this is jogging your memory. Hopefully you remember how to do this stuff. Let's do something where we want to talk about all the numbers between two numbers, because right now we're just talking about numbers greater than or less than, but then you've got all the way out to infinity. What about between two values? Let's actually start from the picture this time. I'm going to draw a picture first. Now let's pick two numbers. I don't know. Let's pick 2 and 6. Sounds good. And let's say I want to talk about all the numbers between 2 and 6. And let's say I want to include 2, but I don't want to include 6. I'm going to draw a dot over 2, a circle over 6, and compare it, or complete it. Now, what kind of numbers are in here? Well, the obvious answers would be things like 3, 4, and 5, right? But also all the infinite number of fractions and irrational numbers. Pi is in there, 4.257 is in there, just everything you can think of that is between 2 and 6, all those numbers. Well, how would we write this in inequality form? Well, there's a couple of ways. We're going to think about how they relate to 2 and how they relate to 6. So how does it relate to 2? Well, these numbers are greater than 2. X is greater than or equal to 2, actually. And for 6, these numbers are less than 6. And you could do that, and we would connect these with the word and, meaning at the same time. So it's greater than 2, but also at the same time has to be less than 6. And we usually don't write it this way because we have a more convenient compound way to write this, where we combine them into one inequality. I'm going to show you how to do that. So if you think about it, I could take this and flip it over. And this, if I reverse it, if x is bigger than or equal to 2, then 2 is less than or equal to x. All right, take a second to think about that. So if I swap these over, the arrow just flips too, because x is being bigger than 2 is the same as 2 being less than x. It's the same thing. And now I can look at this here and this here, and I can say, well, I got an x here on the left and an x here on the right. Why don't I just call those the same x? And I can combine them together and have this new compound inequality that says 2 is less than or equal to x, but also x is less than 6. And this is our compound inequality that gives us all this information right here in one statement. Now, this might look kind of confusing. There's a lot of stuff going on. There's a 2, there's a 6, there's some symbols. A lot of times people see this and kind of think that's a lot. But I try to tell my students, when you see this and you don't get overwhelmed, I want you to think of this statement. This means x is between, let me finish that. X is between 2 and 6. And then, of course, including 2, but not including 6. And you can add that in the English. But every time you see something like this, I want you to think about the statement, x is between 2 and 6, because that's what that means. It's just somewhere between there. Okay, let's do another one just before we keep going, so we can practice doing that. Let's actually start from the inequality this time. So I'm going to give you one. Let's do 1. Let me write that a little better. Less than x, less than or equal to 9. Now, I would encourage you to pause the video, try to draw it yourself, and see if you can get this right. All right, I'm going to assume that you've done this. Let's draw this together. I have 1 and 9. And x is greater than 1, or 1 is less than x, same thing, which means I'm going to have a circle over 1, and x is less than or equal to 9, so that means I'm going to have a filled-in dot here at 9. And remember, in English, this says x is between 1 and 9. So where's my line going to go? It's going to go between them. It's really that simple. Okay, let's do another one. What about this? Again, let's start from the picture with this one. I think it's probably a little better to think of it this way. Let's pick another couple of numbers. Let's say 5 and 10. What if we wanted the numbers to be either 10 or greater, or less than 5? Now, I use the word "or" very, very deliberately, because a number can't be over here and over here at the same time, can it? It can either be on the right side of 10 or the left side of 5. It can't be in two places at once. So we're going to use the word "or." And that's important because we're going to actually use that in our inequality. So we're really just going to write down two inequalities connected by "or." So the left side, I have x is less than 5, or x is greater than or equal to 10. And that's how you do that. That's how we would talk about things that are going off in opposite directions. All right, so that's our review, our very quick, simple review of how inequalities work and how they are graphed. Now let's introduce this new notation. And we're going to do that. I'm going to go back to a previous example, or one like it. Something like this. Let's say you have this. X is between 2 and 6, and we're going to include 6 but not include 2. Let's go ahead and draw it, because we already know how to do that. I'm going to draw my line here. My drawings are getting worse as I go. Arrow, arrow. And here's my 2. Here's my 6. Am I going to notice that there is a non-inclusive 2? We're going to include the 6. And since this means between 2 and 6, I know that my line goes between the 2, just like that. All right. Well, this new notation is going to be motivated by the fact, well, two things. One, this up here is kind of tedious. It's got two different symbols in it. It's got an X, it's got numbers, it's got more stuff than it needs, because all we really want to talk about is this span here. In other words, we want to talk about all the stuff between two numbers. So really all we need to know is the two numbers. This X isn't really even required. So this notation I'm going to show you has an understood X. So I'm just going to write it, and so you can see what this means. I'm just going to write down the left endpoint, which is 2, comma, the right endpoint, which is 6. And I do need to have something that denotes whether they're included or not, right? Because this information is encoded here, or in the dots, but in this new notation, I need something to say whether it's included or not. Well, in this notation, we're going to use a bracket to show that it's included, and parentheses to show that it's not included. And now, this right here has all the information that this picture contains, or this inequality up here contains. And I used less symbols, and it's very, very elegant and straight to the point. And this is called interval notation. And the idea of interval notation should evoke the idea of an interval. If you think about, like, what is an interval? It's like an interval of time is between two times. You have a starting point and an ending point. So whenever you are talking about interval notation, you need somewhere to start on the left and somewhere to start on the right. And the left one will be smaller than the right one. So this is also, and we'll talk about this more soon, this is the lower number. So this is lower, and this is higher. All right, and that's going to come into play a lot soon, and that's going to get a little bit more complicated, so I want you to keep that in mind. Let's do another one. We'll write a different inequality, and let's see if we can convert it to both picture and interval notation form. Let's do 4 is less than or equal to x less than or equal to 7. Now, if you think you can do this, pause the video, give it a shot, and then come back and see if you got it right. All right, here we go. So I'm going to draw my line. Now, converting it straight to interval notation doesn't require you to draw the line. However, as we're going to discuss soon, it's very, very useful to be aware of what this line is. So I'm going to make sure that I draw it first for a while. All right, so I'm going to fill in both dots because they're equal to and connect them. And now in my interval notation, I need the left endpoint. So the furthest point left that I'm talking about. The furthest point left I'm talking about is 4. And the furthest point right, let me get my different color. The furthest point right I'm talking about is 7. And if you notice, they are both equal to's. We're including both 4 and 7, denoted by these things and also the filled in dots. So as I said before, we're going to use this notation with the bracket. And that's very, very simple. That's really all there is to it when you're talking about x being between two numbers. All right, here's where it gets a little bit more interesting. What if I wrote something like this? This gets more fun. All right. I highly encourage you to pause this video before I show you how to do this and try to think of a way to convert this to interval notation. Now, you already know how to draw the picture, right? There's a 2, and we're going to fill this in, and we're going to draw our arrow to the right. That's not too bad. But how would you convert that into interval notation? So give it a shot, pause the video, and come back, and I'm going to show you how we accomplish this. All right, I hope you tried it on your own. And I'm really curious to know, I wish I could find out if you got it right or not, but alas, I'll have to just settle for just showing it to you. All right, so something you may remember from the previous examples is with this notation, we have to talk about a left endpoint and a right endpoint. That's the whole idea. We're talking about intervals between this thing and this other thing. Well, here, we don't have two endpoints, do we? We have the number 2, and that's it. We don't have anything over here. And that makes sense because it doesn't stop, does it? It goes on forever and ever and ever. Well, to use our notation, we have to have something there. A lot of students will say, well, if I don't have anything over there, why don't I just do this? That's a good guess. But it doesn't give you any kind of directionality, right? If I write this symbol, I don't know if I'm talking about things bigger than 2 or less than 2 or just 2, right? So that's not going to be very helpful, although it is a good guess. What we're going to have to do is come up with something to put over there instead of a number. Well, as this number goes on and on and on forever, as we get bigger and bigger and bigger, we have an idea that we can call upon to represent this, and that is infinity. Now, it's worth noting, infinity is not a number. Okay, there's a common misconception. Infinity is not something that you can reach. It's not a number itself. It's an idea. It's a concept. Okay, but for our purposes, it's going to provide us with a right side so that we can make this notation. So now I want you to pay very close attention to this, because this now provides a way to draw our notation. And I have on my left endpoint is 2. My right, it's not an endpoint, but it is something to put on the right. Okay, now on the left, this is filled in, isn't it? So I'm going to have my bracket. Now think about the right side. Do I need to put a bracket or parentheses? And what do those mean? Bracket means that I am including that number. So it's a number that I can find and write down. Well, as we talked about a second ago, infinity is not a number. You can't reach it. You can't grab it. It's not a thing that you can attain. It's a concept that you go towards. So since we can never actually get to infinity, we can't actually include it. So infinity will always have parentheses. You will never see this. That's just not a thing. Okay? So every time you put infinity, you're going to put parentheses. Now, I want to take a second to really focus on something here. A lot of students will try to make the logical connection between this notation and this notation. And they'll try and find patterns and things like, because when you first see this with the infinity stuff, it can be a little weird. It's like, well, when I see this symbol, do I put the infinity on the right or the left? I want to highly encourage you not to think about that. I don't want you to connect the concept of this thing to this thing. This notation really should be connected to this picture. Well, why is that? Because it is really a representation of that. The left side and the right side are visible in this notation. So it's much more useful to think about how this notation shows you this picture. And that's a lot more important than how this notation shows you this thing over here. I hope that makes sense. And I'll kind of expand on that as we do more examples. But it's really important to try not to find any kind of patterns and things like that, because our brains, especially when we learn something new, we try to latch onto patterns. We say, okay, so when the arrow points this way, we go this way. And don't do all that stuff. I want you to think about how this notation fits with the picture, not this thing. Okay, I think I drilled that into the ground too much. Let's just do some more examples. You try this one real quick before we make this more difficult. I'll give you another simple one. Let's do this. Try this one on your own real quick, and then come back and I'll show you the answer, and you can see if you got it right. All right, here's our picture. And again, just like the last one, this is going out to the right forever and ever and ever. So on the right, I have infinity. And again, like I said before, it's important to know that the picture looks like this because this tells you where to put your 5 and where to put your infinity. You cannot put infinity here and 5. Why not? Because they're mixed up. You see that? The left side is the 5, the right side is infinity. Also, this is supposed to say, again, this is wrong, by the way, don't do this. But the number on the right needs to be larger and the number on the left needs to be smaller. And this just doesn't make sense this way. So let's get rid of that and go back and do this the right way. So again, keeping the picture in mind, the left one is going to be 5. The right one's going to be infinity. We do not include infinity ever. And in this case, I'm not including 5 either. So I have parentheses. And that's how that works. Hopefully that's not too bad. All right, what about if we went the other way? Let's try that. So let's say I had x is less than or equal to 3. All right, why don't you guys try this on your own? Now that you've seen how it works on the right side, maybe you can figure out how it will work on the left side. Please try this on your own, because if you just watch and see how I do it, you will never get the opportunity to do this on your own and to think critically about it. But if you just can't wait, I guess you can just watch me do it. All right, I'm going to fill that in and go to the left. We know that. Okay. Well, if I want to draw interval notation, I still have to have 2 endpoints. I have to have a furthest point to the right, furthest point to the left. In this case, the furthest point to the right is the 3. What is the furthest point to the left? Well, there's not one. But we need to talk about what is forever to the left. Well, these numbers to the left are negative numbers. And so we're going to use, this is a thing, negative infinity. Negative infinity is just the idea of going forever in the negative direction. So that is going to serve as our left-hand side. So now, establishing the idea of a negative infinity makes this interval notation quite simple. So I go down here and I say, well, this is negative infinity, and this is 3. Now, do I include the 3? Yes, I do. So I have a bracket, and that's, oh, forgot my comma. And that is our interval notation for x is less than or equal to 3. Not too bad, I hope. And if I wanted to do, let's just kind of keep this ball rolling without getting too bogged down. Let's do another one really fast. So let's say x is, oh, let's make this fun. X is less than pi. I could put really whatever I wanted to. Well, here's pi, and x is less than that. don't let pi scare you. I'm just messing around, trying to have something besides just a couple of numbers. And again, to the left is negative infinity. So my interval notation would be negative infinity all the way up to pi, not included. Just like that. Very simple. Okay. Well, now we have to talk about the case. If you remember back when we started talking about inequalities, what about the case of OR? Let's draw the picture first. What are we talking about here? We're talking about things like this. If I have two numbers, 1 and 4, and I want to have greater than 4 or less than or equal to 1. Let's see if we can write this in inequality notation. That's the original notation. So remember, with the OR thing, you're literally just going to write down two different ones and connect it with OR. So x is less than or equal to 1, or x is greater than 4. And that's how you would write that. Well, how would we write that in interval notation? Give this a shot yourself. See if you can figure this out. Now, you may not be able to do this completely because this is going to require a new symbol that you may or may not have seen before. But you may be able to do something towards it, and will be beneficial to try this on your own for critical thinking. All right, let's see how close you got. So I'm just going to think about this as two different intervals, just on the same line. Just like this is an interval here, or an inequality and an inequality, there's two different ones. I'm going to have two different intervals. So let's write those down. Let's see if I can do it with, well, I'll go ahead and draw them. There's a negative infinity here. So the left one is going to be negative infinity to 1, included. The right one is going to be 4 to infinity, not included. Let me draw that a little better. Not included. And we need something to say that these two inequalities are connected. In other words, this is one thing that we're talking about. We're not talking about these as two separate problems. So there's this symbol that we're going to use. You may or may not have seen it before. It's called union. This is the symbol for union, and this means or. And we're not going to get into set theory and any other kinds of set notation and things. This is sufficient. So whenever you have or with these inequalities, you're just going to connect the two with this symbol called union. All right, let's see if we can let's do another few. See if you can do this one. You try this. I'm going to write down this, and you try to draw the picture and write the interval notation using that new symbol. Okay, here we go. So here's my line, and I've got 2, and I've got 5, and circle over 2, right, because there's no equal sign, dot over 5, because there's an equal sign. X is bigger than or equal to 5, so that's numbers up here. Less than 2, that's numbers down here. So that's our picture. And now let's create our interval notation for this. So on the left one, I've got, well, the furthest point left is negative infinity, not included, right, ever. And all the way up to 2, not included. And I've got union. Oh, my pen didn't register that one. Union. Now, this isn't a U, by the way. It's convenient that union, it looks like a U, but it's not this. So don't draw it with a stem. It's its own symbol, not actually a U. However convenient it is that it starts with U. And now, oh, I was talking about letters and forgot. That's a bracket, 5, infinity, not included. And that's how you would draw that with interval notation. All right. I hope you guys have gotten something out of this introduction to interval notation and this review of inequalities in general. In another video, in the next video, we're going to talk about how to solve equations using inequalities or involving inequalities, and how to write the answers using this new interval notation. This interval notation is going to be really, really useful as we get into graphing and talking about domains and ranges and things like that. But we're not there yet. But again, thanks for sticking with me to the end of the video, and I'll see you guys in the next one.